What's up, people? All right, so I am shooting the sun in detail, so you can see kind of how close I'm getting to the surface here. This is shot with a hydrogen alpha scope. Hydrogen alpha is the brightest emission line in the chromosphere that isn't absorbed by our atmosphere. So, deep infrared, ultraviolet, a lot of that gets absorbed by our atmosphere. This is close to infrared, but not quite. The ionized hydrogen is very, very bright because, of course, the sun is made up of mostly hydrogen, as that's what's being fused to create the light and heat that we see. I wanted to shoot it today because conditions are actually surprisingly decent, although they're getting a little bit worse now. But there's also a lot going on in the sun. Like, look at all these sunspots. There's a sunspot grouping there, more sunspots here. I actually really like this inverted look for looking for sunspots. A whole bunch of stuff going on in here. So a lot of goodies on the sun today. The things hanging off the edges are prominences, not flares. I don't even know if you guys can hear me okay. I don't do this very often. I see questions are like piling in. I'm streaming to multiple platforms, by the way, guys. So I'm not just on Instagram. I'm not just on X or YouTube. So if it's a little confusing to like try to manage it all at once, but I'll do my best. So sorry if it's not formatted right for your device. If you're on like mobile, I know it's a widescreen. Sorry about that. I wish I could like fill the screen better. The only way to do that is basically to put my phone up to the eyepiece, which looks terrible. I figure this is about as good as it'll get. All right, so I'm going to start capturing. What I do is I capture thousands of photos at once. I'll capture them in something called a SER format, S-E-R, which is a 16-bit uncompressed format that allows me to preserve all the data in the image. I capture so many because I use a technique called lucky imaging, which allows me to average out a lot of the perturbations in the atmosphere. And see how it's a little bit squiggly, a little bit shaky. I can get rid of that. So I'm going to capture 2,000 shots per frame, and I'm going to do this across the entire solar disk. So you can see it right there at the top. It says quick capture started, and down here at the bottom it says I'm capturing 81.7 frames per second. So it's like capturing a video, very easy. I know you probably see on a lot of my posts, like, I captured 1 million photos. Well, I don't click capture 1 million times. It's done like in batches. So it's still a lot of work. And I actually didn't stream a lot of the work leading up to that, which was calibrating and focusing. There's a lot of things that need to go into place to get it looking this good already. I actually want more overlap than that. Let's start here. So you'll see through this live stream, what I do is I capture a little photo of one close section, move the telescope, capture another photo of that one section. But each photo is actually like 2,000 photos. And what I'll do is I'll stack those together using specially designed software that allows me to just basically batch stack it. And what it does is it will look for images with the highest contrast, because the higher the contrast in an image that's supposed to be identical, I know the clearer and the more focused it will be. That's very similar to how autofocus works in your camera, by the way. But in this case, it's doing it in post-processing to determine which individual image has what we'll call the best focus. When they're all focused fine. I did a good job focusing, but the atmosphere softens details. And you can see it when if I zoom in here, you can see that details kind of swim in and out of focus, almost like you're shooting it at the bottom of a swimming pool. Now, unlike what your favorite YouTuber may have said, that does not mean that water is in the sky above us. There's not an ocean above us, above the dome, as they say. It just means that there's a different refractive index for different layers of the atmosphere. So as they mix, you get basically an out of focus image. So That's okay. I can work around it because it's not too bad today. This is probably what most would consider average scene conditions, but for where I live, this is actually really good, which is why I'm taking the time to do this. When it's bad, there's no point because the image will look terrible. And in fact, my stacking software won't even work if it's too bad. I'm glad you guys are enjoying the live stream. So a little bit of like seeing how the sausage is made. So I don't know how interesting this is, but I think it's really cool just seeing what's going on in the sun and showing you guys a little bit about how this is put together. Hopefully gives you a little bit more respect for not only my work, but also gives you an idea of how accessible this is. So the telescope I'm using, it's I wish I had I wish I was on my phone so I could just like turn it around and show you, but since I'm on my laptop, I can't really do that. But the telescope I'm using is only a 5-inch refractor. It cost me like $600 when I bought it. It's not that expensive. The modifications to it are a little bit more expensive. That's when you get into the 4-digit price point. And the camera is actually more than the telescope. The most expensive thing about this is actually the mount that it's sitting on that allows it to keep it stationary relative to the sun. Because of course the Earth is moving. So the sun you see move across the sky because of Earth's rotation. And if you don't have a platform that's designed for that, the sun will drift out of frame very quickly as I do this, which of course I don't want. So yeah, the most expensive part is the mount that the whole telescope is sitting on, which always surprises people, but it's actually the most important part of astrophotography. I'm going to check my memory real quick here too. Obviously, capturing this many frames fills up memory quickly, but right now it looks like I'm in good shape. So I have everything being written to an SSD at USB 3.0, so pretty high speed. Yeah, the seeing's not fantastic anymore, but that's okay. I'll do what I can in post. I was hoping it would stay as good as it was right before I launched the live stream. It was like really, really good, and I got really excited, but I realized I hadn't eaten breakfast yet, so I went inside, ate breakfast, came back out, and it was gross again. So, I really should have jumped on it when I could have. But I really wanted to do this live stream, and I figured you guys didn't want to watch me eat. I actually didn't even finish my breakfast. It's still half behind me. So I should probably finish eating that. If you see me disappear for a minute, it's probably because I'm like shoving egg in my mouth or something. So one of the things that I really have to focus on during this is making sure I get enough overlap in my panels. That is not too hard. What I do is I just kind of remember little features. Like here, there's this little sunspot that I watched, and I want to make sure that I have like 50% overlap in my panels. The reason I want so much is that in case an individual frame is bad, I want that frame to not have to occupy as much space on my final mosaic, because that frame will have to be really pushed hard in processing. And actually, I can tell right now this frame is going to be probably the worst. Seeing got really bad during this capture. So I can wait to see if it settles down, or I can just move on to the next one. I think I got enough clear frames to just move on, so I'm going to just move on. But if it stays like this, I might actually have to stop and shoot the whole sun over again. Because unfortunately, the sun is also rotating. So if I take too long to capture this mosaic, what I'll end up doing is getting rotation artifacts between each line in the mosaic, which of course I don't want. So yeah, I have to actually do this kind of quickly. People always ask, how long does it take you to capture? Well, it's like technically capturing mosaic of the sun will take me like 20 minutes maybe. However, it might have been my third or fourth attempt because if the conditions get too bad, like I'm saying, and I wait for them to improve, a lot of times I end up having to just start over. In this case, it looks like it got a little bit steady again. So I'm okay to proceed. But if it stayed rough, I would have actually canceled this whole thing, started from the beginning and started over. So just a little insight on why this can be very difficult. And look at that nice prominence there. So that prominence is like massive. So top to bottom of my screen there is probably 150,000 miles. Just to give you an idea, just the insane scale that we're looking at here. That's just a ballpark, by the way, guys. So if you're like, bust out the calculators and prove me wrong, go for it. But it's pretty huge. I'm kind of switching back and forth between like my little Sharp Cap, which is my capture software, and the stream, so I can look to see if there's any questions. Unfortunately, it's actually really hard to it's really hard to like juggle all these chats. That's funny. I see Bray in here. I think he's on Twitter or X. He said, "What chat are you reading, Andrew?" Well, right now I'm reading yours. So yeah, there you go. But yeah, there's chats coming in all over the place. So honestly, I wouldn't expect me to be able to follow along with it. So if I don't answer your question, just ask me later. All right, let's keep moving. So again, to watch the overlap, I'm just looking at these features. I look for little patterns, like right here. I was looking at a pattern that was right here, and made sure when I slewed the telescope over, that one was just still in frame. So, oh god, that's pretty bad. I think a plane just flew right by the sun, and anytime that happens, like the jet wash just really screws things up. So, yeah, not great. All right. I mean, I should really probably capture this one again. I just don't see it getting better. So I'm torn. I either give up or just proceed and have that one bad frame, hopefully. Man, it's getting really bad. So that's, if you ever see me post just half a sun, it's because I got this far and the scene conditions never got better. So that happens, unfortunately, quite a lot. There's a lot of things that I've actually never shared with you guys just because this happens. You see how blurry it kind of gets right here? It gets all blurry and shaky, and then it just never gets better. Unfortunately, that's just kind of the norm here. I don't get good scene conditions very often. So when I do, I just really have to capitalize on it. Somebody just asked a great question. How does it look so stable when we rotate? That is because of the expensive mount that it's on. I have it on a German equatorial mount, which compensates for Earth's rotation. It is the most expensive part, or at least it should be, the most expensive part of any astrophotography setup. Hope you don't mind. I'm going to have some coffee here. One of the reasons I wanted to do this live stream was because when I tried to live stream the eclipse, it kept freezing. And I wasn't sure if that was just a Starlink issue, because I was using my Starlink for the first time, if it was I don't know, just like a bandwidth issue because so many people were probably trying to live stream at the same time. So maybe StreamYard got the servers got overwhelmed. I don't know. But I was really disappointed because it froze like 10 seconds before totality. So, what I promised to everybody, I wasn't able to deliver, which is always really frustrating. Okay, now I've got another problem. So my mount is actually drifting right now. So the worm on these mounts have been through hell and back because I'm just, I don't know, honestly kind of rough with them. So sometimes they'll just drift. When that happens, I have to shoot the frame over again. So I tried to put it back where it was. I might have screwed that up. And then I'm shooting it again. All right. By the way, guys, if you're wondering why it just keeps getting inverted like this, that's an easy way. I can just check the features. I find it's a little easier to look at the contrast when it's inverted. Just something about the way our eyes work or something. I don't know. But it's also why, well, one of the reasons why when you see my solar images, they're partially inverted. They're partially inverted because I'm not sure if you've been paying attention here, like on the lunar or solar limb, but it just seems to kind of drop off into black. Well, that's not actually what it does. There's actually stuff going on here in the blackness of space. It's just very faint. When you brighten it, you can see prominences. Well, not right now, because apparently there's no prominences right there. But the prominences are much, much fainter. So I would want to brighten that, which makes this weird transition between the kind of blackness of space and the solar disk. So the answer to that is I invert the disk and I hide the transition for the inversion along the solar limb. So just a complicated way of saying, yeah, when I process these images, they are usually inverted. Not always, but most of the time. It's actually somewhat of a more accurate way to look at the photosphere too, because what you're looking at right here, with the exception of the sunspots, you're actually looking at the silhouette of the chromosphere. So think of like a light bulb and dust on a light bulb. Like if you got a light bulb like really dusty and they got that dust was just kind of blocking some of that light a little bit, that's very similar to what the chromosphere is doing to the photosphere here. So the reason you're seeing these little dark grassy patches is because the chromosphere is absorbing the hydrogen alpha light put off by the photosphere. And so I'm really only seeing it in silhouette, which means if I invert it, it's actually a more accurate view. However, sunspots are always dark naturally. It doesn't matter how you look at them, they're dark. So when I invert the chromosphere, the one thing that changes that's now no longer accurate is the sunspots. The sunspots show up as bright spots instead of dark spots. So when you see bright spots on my inverted solar images, those are actually dark sunspots in real life. But the rest of the solar chromosphere is actually kind of a more natural way to look at the chromosphere, even though technically it's inverted. All right, so my mount is actually drifting quite a lot here, but the conditions are steady. So I'm just going to plow ahead. So what might have happened is I might have actually missed a frame when I shot this, or not missed a frame, maybe misaligned a frame, just because there is so much drift happening and I'm kind of distracted talking to you guys. So what I'll do is I'll do a very quick stitch of this when I'm done and just see if I missed any panels. I have special software that allows me to pull one out of every 2,000 frames. I'll then take all those frames, the entire mosaic, run them in through Photoshop and try to assemble a very quick mosaic just to make sure I covered the whole sun. And if I didn't, I would go back and very quickly capture that panel I missed. And very quickly, because if I wait too long, like I said earlier, the sun's rotation will actually screw it up. So I have to make sure that I get this right. I'm not sure if you can hear, there's my neighbors next door. I hear some kids crying. My observatory is right on the edge of my yard. So sometimes you can hear dogs barking and all kinds of stuff. My dog is actually just like kind of passed out like right outside my observatory right now. She's super cute. She just likes being my buddy while I do this. So right now I'm running into some memory issues. It honestly is probably because of the live stream. But you see up here, it says writing buffered frames. The camera actually has an internal buffer that allows it to store data as it's pushing it into the computer. So if the computer's not processing those frames fast enough, it will actually back up. And then as a result, I have to wait to capture my next frame. Something I really don't like doing because, as I said, I have a limited amount of time to capture these since the sun is rotating. So if it takes too long, then I kind of have to go back and start over. So I have to keep an eye on memory as I do this. Oh, shoot. All right, let's fix this. I got to cancel that one because the scope was drifting, but I corrected for the drift in the wrong direction. I corrected for it west instead of east, I think. So apologize, guys. I haven't really been looking at chat. I've been really paying attention to this. So I think the live stream is actually frozen.